Hello guys, welcome to another video. So today is 22nd December, which is the birthday of Srinivasa Ramanujan, with the one and only genius of India. And of course, he was a mathematical prodigy. And today in this video, we're going to look at some of his works from some pages of his lost notebook, which are actually available to read for free in Google. So we will take some of the excerpts from that and we will try to understand what actually he did. So let's start with this because I've chosen a topic from his notebook one, which the audience can understand and relate and see how mesmerizing it is. Because there are obviously Q theta functions and mock theta functions and many other things. There are so many things, but of course we have discussed about the gamma function and stuff like that. So probably this is going to be a better exercise for us to see what he has done. So as you can see, his notebooks are like full of identities and results, and these are not trivial to say. So, for example, if I look at example 14 plus 1 here, you see this one, right? So, this example here, this is again an infinite series, right? So, if I attempt to do this infinite series, it seems ki I have k equals to 0 to infinity, and he has given a minus 1 to the power k, and then he has given 3k plus 1 into 2 to the power 3k plus 1. Okay, so these identities, which he usually what happened in his notebooks is he used to give out these identities. This is a very basic one compared to what he actually gives out, but he usually never provided any proof. So if I go to the previous page, what happens is you can see he has defined a formula for an, which is saying that it is 0 to x, 1 by 1 plus e to the power n. A1 is log of 1 plus x, right? Because this is all we know that 1 by 1 plus u ka integration from 0 to x should be this. A2 is tan inverse x, and then he goes on. He goes on to do A3, A4, A5, A6, A7, A8, and everything, A10. So you see the identity in A10. Is this even a thing? So you can obviously try it out yourself. One thing that comes to my mind immediately thinking about this integral, which was written there, 0 to x du by 1 plus u to the power n are the roots of unity, right? Because we have learned ki u to the power n plus 1 can be factorized as u plus alpha 1 and all the way up to u plus alpha n, where alpha 1 to alpha n are the roots of this equation, which can be found out using the concepts of roots of unity. And if that is so, we might be able to write this integral as 0 to x du by this u plus alpha 1 u and all the way up to u plus alpha n, and there exists a partial fraction decomposition of this thing. So basically this can be written as a sum of 1 by u plus alpha 1 plus 1 by u plus alpha 2 and all the way up to 1 by u plus alpha n, each of the fractions multiplied by a specific constant, let's say c1. You can decompose it. You can try it in the case of 2. So let's, if it was rather 1 plus u plus 1 into u plus 3, you can rather decompose this like this half and you multiply 2 here and then you write 2 as u plus 3 minus u plus 1. What becomes is this, you simply have half u plus 1 minus half u plus 3. So here the constants are half and minus half with 1 plus 1 by u plus 1 and 1 by u plus 3. You get what I'm saying? So this can be repeated for n number of terms. So obviously this can be written as a finite summation of n terms, k equals to 0 to n minus 1. And let's say we have this 1 by u plus alpha k plus 1. And let's say the constants are ck plus 1. I would simply write it as k equals to 1 to n rather. So this reduces to the fact that this is a finite summation and k equals to 0 to n minus 1 ck plus 1, and 0 to x du, there should be a du by u plus alpha k plus 1, right? And therefore, this integral can be simply written as k equals to 1 to n se likh lo, because it is from k equals to 1 to n now. If I change the index, it simply becomes ck, and the integration of 1 by u plus alpha 1 is ln of u plus alpha k plus 1, right? So put in the value, you simply get ck into ln of, I think, x plus alpha k by alpha k. This is your answer, where ck and alpha k are to be determined. And then you have to find out, basically the real part, obviously. So we can do it in this way. I think some of the questions could be done in this way, but that remains to be seen again, if we can employ this method and how long, I mean, up to how much is it even feasible. But this can be found out by rote calculation, and he did that as well, because this seems almost impossible to achieve. So let's get back to the question at hand, this infinite series, right? So you see a 3k plus 1, you see a 2 to the power 3k plus 1. So this things, right? How do we even approach this? So one way that immediately comes to mind by seeing a 3k plus 1 and a 3k plus 1 here is, what if we take this k equals to 0 to infinity x to the power k, right? So what happens when I have x to the power k? This is basically 1 by 1 minus x when 0 less than x less than 1. Okay. So this is valid. This is a geometric series. Now, if you change x to x cube, what happens? It simply becomes k equals to 0 to infinity x to the power 3k, 1 by 1 minus x cube, and the condition still holds, 0 less than x cube less than 1. Correct? Now change x to minus x. Now this becomes k equals to, this holds actually for minus 1 to 1, obviously. So you can cancel off the 0. So k equals to 0 to infinity, minus 1 to the power 3k, but you will realize that minus 1 to the power 3k is same as minus 1 to the power k, since minus 1 whole cube is minus 1 itself, which means this is simply this, and this becomes 1 by 1 plus x cube. The condition remains the same. Now, if you integrate this from both sides, what happens? So if you were to integrate this from 0 to half, this summation k equals to 0 to infinity, which is supported by Fubini's theorem, which is a theorem which allows you to interchange the signs of this integrals and summations. This is x to the power 3k because it is convergent, right? This is absolutely convergent, this summation. So what does absolutely convergent mean? So even if you take the mod of this summand, it will still converge, since 0 minus 1 less than x cube less than 1, right? So therefore, this would simply become 0 to half dx by 1 plus x cube on both sides. And on the left hand side, we can simply interchange the summation and write it as k equals to 0 to infinity minus 1 to the power k, 0 to half x to the power 3k dx. Okay. And this would become 0 to half dx by 1 plus x cube. So what is this thing? This again would become k equals to 0 to infinity. Now, if you perform this integral, you will get exactly what is given in the question, because whenever you see 3k plus 1 and then 2 to the power 3k plus 1, it is, you have to notice that this has basically emerged from an integration problem, and this is equals to kitna, 0 to half dx by 1 plus x cube. Okay. Now, if you go back here and see what a was defined, so he has defined a as this, a n as 0 to x du by 1 plus e to the power n, right? For some x. So we can define it for 2x. And what is the value of a3? A3 is 1 by 6 log of 1 plus x cube whole cube by 1 plus x cube plus 1 by root 3. So a3 is simply 1 by 6 log of, in our case, if you remember, this integral x is half and n is 3, which is why we are taking the value of a3. So a3 should be 1 plus half whole cube, which is 3 by 2 whole cube, by 1 plus 1 by 2 whole cube, which is 1 plus 1 by 8, and then plus 1 by root 3, and then you have tan inverse root 3 by 2 in the numerator, and 2 minus half, which is 5 by 2, right? Which is 3 by 2, sorry, 2 plus half is 5 by 2 anyway. So this would give us 3 by 2 whole cube. So 1 by 6 logarithm, if you multiply by 8 up and down, I think you get 27 by 9, and here you get 1 by root 3 tan inverse. So 2 and 2 cancels off, and root 3 and 3 cancels off, and this becomes tan inverse 1 by root 3, correct? Tan inverse 1 by root 3. Now, therefore, this becomes 3. So 1 by 6 log 3, and tan inverse 1 by root 3 is nothing but 30 degrees, which is pi by 6 plus pi by 6 root 3. Let us go back and we see this is exactly what we were asked to prove. So we can do this kind of sums, but not all of them, because as you go along the notebook, it becomes harder and harder. So you will require a lot of patience and a lot of knowledge and creativity to even attempt these questions. So yeah, this was some of the easier ones, but I do not think anything further than this would be a suitable topic to discuss on YouTube. Anyway, my calculus crash course is live as well, and chapters are getting in. Live sessions are going to be conducted from the next week as well. So be sure to tune in and maybe buy the course if you like. So thank you for watching.